Analysis and design of web-tapered beams and columns using finite element analysis in portal frame buildings. Abstract. A need is identified to introduce web-tapered portal frames to Indian conditions and practices, due to the apparent financial advantages and the unstable supply of hot-rolled members locally. This study will bring together various aspects that need to be considered for the design of web-tapered portal frames and review if this method of construction is safe and worth pursuing as an alternative to conventional building techniques. The present investigation aims at comparison of conventional steel building and building. In this investigation, analysis of and design of web-tapered portal frames building and conventional steel building will be carried out for spans like 20 m using computer software Staad Pro V8i. 11 Web-tapered steel portal frames is ideal for construction in remote and hilly areas. Keywords: web-tapered portal frames, conventional steel building, Staad Pro V8i. Introduction. To achieve greater economy in material use, web-tapered steel members, where deeper cross-sections are used within the regions subjected to larger internal forces, are commonly employed within steel structures. However, the methods provided in current structural steel design specifications for the instability assessment of web-tapered steel members are based largely on those developed for prismatic steel members, often leading to overly conservative estimations of their ultimate strengths and thus limiting the efficiency gains achieved through their use. Objectives of the present study. 1. Create a structural optimization algorithm capable of finding the lightest possible frame, when subjected to various load combinations and design constraints. 2. Confirm the reported material savings potential of web-tapered portal frames designed with finite element analysis method against conventional portal frames. Web-tapered portal frames. Web-tapered portal frames are on an average 30% lighter through efficient use of steel. Primary members are tapered built-up sections, with large depths in the areas of highest stress. In this type of buildings, all the structural elements are designed as per the bending moment diagram obtained. According to the bending moment diagram, the steel sections are tapered. The specimens are manufactured at the factories as per the customer's requirement, and then it is transported to the site. At the site, by proper cutting and welding, erection process is completed. See advantages of web-tapered steel portal frames. There are many advantages of web-tapered steel portal frames, which are as follows. 1. Quality control is the main advantage, as all the structural member are engineered beforehand. Standards of different codes also taken into consideration, and these components are made in factory under the supervision of quality control engineer. 2. Lower cost due to the saving in design, manufacturing, and on-site erection cost. 3. Minimizing time of construction due to the use of software for design of the structural components. 4. Low maintenance due to use of standard quality of paints over steel members, which increases the ability to withstand, and finally the maintenance cost will be low as compared to conventional building. 5. Quick erection, as all the members are pre-manufactured and skilled labor is used for connections of different components. 6. Warranty on web-tapered steel portal frames, mostly warranty period of 20 years given by manufacturers for web-tapered steel portal frames. Conventional steel buildings. Primary steel members are selected from standard hot-rolled I section, which are, in many segments of the members, heavier than what is actually required by design. Members have constant cross-sections regardless of the varying magnitude of the local stresses along the member length. Steel has many advantages like ductility, flexibility, strength, etc. Because of this factor, they are more stable, and steel offers high speed for the construction from the start of work. Usually for conventional steel buildings, hot-rolled structural members are used. In CSB, all the steel members are fabricated at the manufacturing unit and transported to the site. By welding and cutting, erection process is done. Trusses are the examples of conventional steel buildings. 2. Problem statement. A problem statement of web-tapered steel portal frames buildings and conventional steel buildings. Long-span column-free structures are most essential in any type of industrial structure, and web-tapered steel portal frames fulfill this requirement along with reduced time and cost as compared to conventional structures. In this project, range of spans will be decided for which web-tapered steel portal frames can be provided economically. A comparative study of web-tapered steel portal frames buildings and conventional steel building for spans 20 m is to be carried out. 1. Conventional steel building structure parameters. 2. Web-tapered portal frame structure parameters. 3. Results and discussion. A. Maximum deflection, in mm, at center for 1.5, dl plus ll. Maximum deflection at center for web-tapered portal frames and conventional steel buildings by using Staad Pro software. Fig. 9. Maximum deflection, in mm, of web-tapered portal frames and conventional steel buildings by using Staad Pro software. B. Weight of steel, steel takeoff, 4 purlin in kg. Weight of steel, steel takeoff, 4 purlin of web-tapered portal frames and conventional steel buildings by using Staad Pro software. Fig. Point 10. Weight of steel, steel takeoff, 4 purlin of web-tapered portal frames and conventional steel buildings. C. Weight of steel, steel takeoff, 4 column in kg. Weight of steel, steel takeoff, 4 column of web-tapered portal frames and conventional steel buildings by using Staad Pro software. D. Weight of steel, steel takeoff, 4 rafter, vertical and inclined members in kg. Weight of steel, steel takeoff, 4 rafter, vertical and inclined members in kg of web-tapered portal frames and conventional steel buildings by using Staad Pro software. Fig. Point 12. Weight of steel, steel takeoff, 4 rafter, vertical and inclined members of web-tapered portal frames and conventional steel buildings. E. Weight of steel, steel takeoff, 4 tie member to column in kg. Weight of steel, steel takeoff, 4 tie member to column in kg of web-tapered portal frames and conventional steel buildings by using Staad Pro software. Fig. Point 13. Weight of steel, steel takeoff, 4 tie member to column in kg of web-tapered portal frames and conventional steel buildings. F. Total weight of steel, steel takeoff, in kg. Total weight of steel, steel takeoff, in kg of web-tapered portal frames and conventional steel buildings by using Staad Pro software. Fig. Point 14. Total weight of steel, steel takeoff, in kg of web-tapered portal frames and conventional steel buildings. G. Total reactions in Kn for 1.5, dl plus ll. Total reactions in Kn of web-tapered portal frames and conventional steel buildings by using Staad Pro software. 4 conclusions. Nowadays web-tapered steel portal frames concept has been very successful and well established. 1. The maximum deflection, in mm, of web-tapered portal frames is more 83.42% than of conventional steel buildings. 2. The weight of steel, in kg, of web-tapered portal frames is less 15.38% than of conventional steel buildings. 3. The weight of steel, in kg, 4 column of web-tapered portal frames is more 15.22% than of conventional steel buildings. 4. The weight of steel, in kg, 4 rafter, vertical and inclined members of web-tapered portal frames is more 15.22% than of conventional steel buildings. 5. The total weight of steel, in kg of web-tapered portal frames is less 28.21% than of conventional steel buildings. 6. The total reactions in Kn of web-tapered portal frames is less 15.076% than of conventional steel buildings. 7. Web-tapered steel portal frames construction reduces the weight of building than conventional steel structures. 8. It reduces the amount of steel requirement, reduction in dead load reduces the size of foundation. 9. Web-tapered steel portal frames construction is 30 to 40% faster than conventional steel structures. 10. Provide good insulation effect and would highly suitable for a tropical country like India. 11. Web-tapered steel portal frames is ideal for construction in remote and hilly areas.